All right, so these algorithms are basically identify and plug in. Okay. The difference of squares is factoring a quadratic. Okay, and these are cubics. So last two methods we're going to study. The difference of squares comes up quite a bit, so it's pretty useful. Sum of difference of cubes is kind of an auxiliary factoring method that comes up a few times in calculus. Very rare. Okay. So the difference of two, what you're looking at is the difference of squares might look like this. Can you factor that quadratic?
Yeah.
Okay, so what? Oh, my key? Forgot mine today. Switch vehicles, left them in the other one. Okay. There are two squareds here, right? Two squared? So you're looking for this second number. Doesn't necessarily have to be a perfect square, but it does make it easier. Can you factor that? It's the same as 0x. Okay, those are the same statement, right? So can you factor it? Two numbers that multiply to get -4, add to get 0. Yeah. And there's your algorithm. So if you can identify what's squared, like the 2 is squared, you just plug it into x minus and x plus. So not necessary because you can still factor this way, but it does make your life faster and easier. Okay. How about twist to it. So there's a 4 in the front now, right?
Yep.
So how can we deal with that?
You can just take a 4 out of both of them, can
Okay, that's an option. Yeah. So we have a 4x squared minus 4. Yeah. And what's our factored form? Same as up here, right?
Yeah.
Okay, that was not my intent, but that's okay. Mm-hmm. Yep. Could. Yeah, that's probably the best way to do it. So, well done. Okay, let's try a different one. That one. What's the squared term here?
2x.
Yeah. So I can rewrite it as such. Right? Now I have a difference of 2 squareds, and I use the algorithm. So what would the factorization be? 2x. There you go. Okay. So identify the squared terms, plug them in. That's what you're looking at. any questions on that? You want me to give you another harder one? And you can, basically what it is you just add more terms to each of those.
Yeah.
And it's the same algorithm every time. You just have to identify the squared terms.
Let's just go on to the key. Because I feel like that's going to take some time.
It's not really the algorithm. It's the same style here. Okay, so let's do the difference first. The difference and the sum are the same algorithm, they just differ by a plus and a minus. Okay, so if you can do one, you can do the other pretty quickly. So it's, again, an exercise in identifying the cubed terms, and then you just place them in the right spot. So the first is, will always match. Okay, so that's what's nice. The first term here, the binomial will always match what's here, x minus y. And then what's in the quadratic portion is x squared plus xy plus y squared. So it's just all addition. So if you want to memorize this and remember it, these match, and that is the opposite. Has to be a quadratic. But if you multiplied these together, it would end up back at the beginning. So that's our algorithm. You just plug everything in that you get.
Okay, that makes sense.
So try this. We'll start easy. That was on the worksheet, right? One of your answers that you got?
Yeah.
Okay, so identify the cubed terms. What do we have?
Y minus 2.
2 cubes? Okay. Now plug in. Yeah, okay, that matches. First term squared, and then multiply these two terms, 2x, and then 2 squared.
Okay.
So you see how the progression works?
Yeah.
It's squared, multiply, squared. That's how this quadratic is. So you basically have this in terms of y. Put it in the right spot. Not so bad. Just looks ugly and before you've ever seen it. And then if you really want to, you can. Right, that's fair. So are you okay with that?
Yeah.
Okay, how about a thumbs up from you? Or a thumbs down if you don't get it, everybody. Or a sideways if you're counting it. All right. Okay, let's try one like a little bit more into it. Yeah. 64. That's 6 kind of tail. what is 27 as a cubic?
3.
Yeah, so 3y, right? And what's 64? 4, yeah. So you now have identified your cubic terms. Plug it in.
So the 3y minus 4z.
So that should match, right? And then 3y squared plus 3y times 4z plus 4z squared. Same pattern every time. So the middle term is always these multiplied, and then the ends are squared. Can you read that?
Not the very end yet.
So put them in the right spot. And it is mathematically proper write things out. They do that on purpose. Maybe I was just testing you.
OCD.
Yeah, you know me. Some 80s rap joke. Okay, you okay with that?
Yeah.
Then you're okay with the sum of cubes as well, because it's all that differs is the signs. Plus, plus, minus, plus. Okay, so we write it down for you, and we can be done. Okay, first term matches, and the second term just has one negative, one minus in it.
Do that y squared at the end.
What did I write?
Y cubed.
Yep. Just testing you. Because I do that all the time, right? You'd think I wasn't very good at this. We calculated why I never score 100 on a test. Make stupid mistakes. Do you need to see any more examples?
No.
Good?
No, until we actually have. Yes, we do.
I don't.
Do you seriously want to go through another one? Yeah, exactly.
Okay, there.
Yes, you will. Do this in absence.
I don't recall if I actually posted this yet. That was my intent this morning when I got distracted.
Yeah, I know the picture. Yeah.
Does that say
Yeah. Today is not on point.